What was the atmosphere when reactor 3 was operational? What was the atmosphere when reactor 4 exploded? Here you can see the working places of the shift engineers. Yeah. Here was the working place of a reactor control engineer. At reactor number 4, it was Leonid Toptunov, reactor control engineer. Nikolai Stolarchuk, that was the working place of a unit control engineer. Then, turbine equipment control engineer, Igor Kirschenbaum. And in the middle, there was the working place of a unit shift supervisor. His name was Alexander Akimov. Here was his working place. You can see here a principal scheme of a very compact reactor at this very table. Yeah, a principal scheme. You can see a reactor core, which is shown, which is in the center. That is the heart of a reactor, the reactor core, which is 7 meters deep, 12 meters in diameter. It's a cylinder-shaped structure with graphite columns inside. Graphite columns, yeah? Graphite moderated. Holes were inside these very columns for channels. It's a channel type reactor, yeah? An upper reactor plate, this very structure, an upper reactor plate, you can see it at this very board, control board, this very structure, upper reactor plate, yeah? 2027 all in all channels, white cubes. These are for nuclear fuel, yeah? Channels for nuclear fuel. Just imagine what was used for as nuclear fuel for this very type of reactors. Yeah. Low enrichment uranium oxide. Yeah. 192 tons of uranium oxide were inside the reactor 4. Yeah. Reactor 4 was fueled completely before the explosion. 192 tons. Yeah. Colored cubes. These are special cubes for special channels. The majority of them were for control rods. Yeah, all the processes which were running inside the nuclear reactor, they could be regulated by these very control rods. Started from the regulation of the level of capacity up till the reactor complete shutdown. Yeah.
So that's boron.
Huh?
Control rod is made of boron?
Control rods, well, yes. You see how the capacity was regulated. Control rods were completely inside, yeah, the reactor was shut down. Removing them, the capacity was increasing, right? On that very night, you know, the 26th of April, they were going to shut down reactor number 4 for a scheduled repair activity, yeah? And at the same time, they were planning to conduct the equipment testing. So on the eve, they began to lower the capacity of this very type of reactor. So the 25th of April, the capacity was 50% lowered. 50%, yeah. So they did not have a permit here at Chernobyl site. They did not have a permit to lower the capacity further from Kiev, a permit from Kiev, because there was a lack of capacity in a system. Yeah. So the reactor number 4, it was operational for a rather long term, yeah, at a low capacity, 50% capacity. And only later on, it was clear that this very type of reactors, they are very poorly, yeah, regulated at low capacities. Well, you know about this very testing, the equipment testing. What was the task of it? to get the information whether it is possible to use the rest capacity of turbogenerator rotor as an additional source of power supply for safety-related systems, including, for example, reactor cooling systems. In case of a complete loss of power supply, then this something. Well, it's an ordinary situation. It was an ordinary situation. Well, so in the program for this very testing, it was written that this very work should be completed at 700 megawatt of thermal capacity. 700. So they began to lower the level of capacity. And while switching from one mode of capacity regulation to the other mode, there were some technical problems within which they lost the capacity. There was a sharp decrease of capacity up to 30 megawatt. 30, yeah? The nominal was more than 3,000, yeah? There was a sharp decrease up to 30 megawatt, yeah? The situation became rather serious. Why? Because the reactor poisoning began, yeah? First of all, xenon poisoning, the products of uranium fission poisoning. To neutralize this very situation, it was necessary to wait. Dyatlov, Anatoly Dyatlov, he was at the control room of unit number 4, and he had the highest position among them. That's why all their decisions should be agreed with him. Yeah? He realized that there was a risk that they won't complete this very testing. Just imagine, Chernobyl nuclear power plant, it was one of the best in the Soviet Union. It was named after Vladimir Lenin. Yeah. There shouldn't be any situation like this. All the tasks should be completed. So Dyatlov insisted on the increase of the level of capacity. Toptunov and Akimov, they didn't support this very decision. Yeah? They thought that it was not a good idea to increase the level of capacity in this very situation. The reactor was not controllable enough. Yeah. Dyatlov insisted. He told them that they were not professional enough, experienced enough. He insisted, yeah. Toptunov managed to increase the level of capacity up till 200 megawatt. The capacity was stabilized at 200 megawatt. Sometimes people ask, was it possible to prevent the explosion? Some of the experts now say that it was. And that was this very moment when their capacity was stabilized, yeah, 200 megawatt. That was this very moment when it was necessary to stop, not to prolong the equipment testing. It was necessary to stop, to decrease the level of capacity, but not pressing AZ5 red button, but to do it manually, yeah, slowly, step by step, up till a complete reactor shut down. This very chance, this very moment, it was not used, it was lost. At this situation, when reactor was not stable enough, was not reliable enough, Dyatlov gave a command to stop the equipment testing. The turbines were stopped, and the main circulating pumps, they ensured the circulation of a coolant in a primary circuit. Yeah, they pumped water to the reactor core for their fuel cooling. Yeah. they began to run using the rest capacity of turbogenerator rotor. Yeah. There was a lack of capacity, not enough capacity for them to pump water. There was no enough water here in the reactor core. Sometimes this very type of reactors, they are compared with a teapot, yeah, which was placed for heating, but without water. The situation was the same. Yeah. Well, so Toptunov, yeah, the reactor control engineer, his working place was here. He was the first who noticed the beginning of the development of the accidental process, the temperature increase in the reactor core, the amount of steam increase, the steam pressure increase, yeah, and what was the most important, the capacity began to increase. At first slowly, but then faster and faster. He reported Akimov, and Akimov gave a command to shut down the reactor. Yeah. Toptunov pressed, pushed, as a 5 red button. We are at the control room of unit number 3. So here, a red button just like this, it was replaced by a key. Reactor number 3 was shut down by turning a key. But in April 1986, at the control room of unit number 4, it was a red button just like this here, and it was pressed, pushed, to shut down the reactor. This very device, it was designed, yeah, to shut down the reactor in any situation, emergency, not emergency, to shut down the reactor. According to all the rules, after its pressing, all the absorber rods, which were in their maximum upper position, 211, they had to go to move down, yeah? They had to move inside the reactor core. The response time of this very system was 18 seconds. So within 18 seconds, the absorber rods should cover the distance of 7 meters, yeah, to be completely inside the reactor core. Suddenly, they stopped. They began to move, but they stopped. And these very devices, they were called cell synths, yeah? They showed the position of a rod inside the channel. They began to beep, 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 yeah? The absorber rods were blocked at Mach 2.5 meters. Why? Why they had been blocked? Because the channels, they moved along, they had been destroyed by the increasing steam pressure. The geometry had been changed. They couldn't move along. Yeah. They were blocked. The absorbing part, which was 5 meters long, it was outside the reactor core. Yeah. The graphite displacers, which were located at the tip, they were inside the reactor core, but they didn't absorb neutrons. That's why the capacity began to increase, yeah. Several seconds after, as a 5 red button was pushed, there was an explosion. Instead of being a reactor shutdown device, in this very environment, under these very circumstances, yeah, reactor, this very system became a reactor, a runaway device. Yeah, runaway device. We have mentioned operation reactivity margin. Yeah, operation. It was a fatal step. Toptunov, managed to increase the level of capacity before they started their testing. He managed. What was the price? He removed some additional absorbers out of the reactor core. Instead of 30, there was only 18. Yeah, that was the price. He managed to increase the level of capacity, removing some additional absorbers out of the reactor core. This step became fatal, because this very system, reactor control and protection system, became less effective. Yeah, less effective. When this accidental process began, temperature, the amount of steam increase, steam pressure increase, yeah, the increase of capacity, there was nothing to impact reactivity. Yeah, this very system was ineffective. There was nothing to impact what was reactivity? The nuclear reactor capability to run away, the coincidence, yeah, of all the circumstances, including humans factor. There were mistakes of the personnel, but they were not so critical, maybe, yeah, to cause the explosion. By the way, what was the technical cause of the explosion? It was known very soon after the explosion. Very soon. The so-called the end effect of absorber rods. But it was not mentioned. You know, an international conference, IAEA conference, at the end of summer 1986, the Soviet delegation headed by academician Legasov, yeah, he reported what had happened, why it had happened, what were the causes, the consequences, what were the deeds of a personnel, but it was not mentioned. The end effect of absorber, these specific design features of control and protection system, yeah, specific design features of their absorber rods. It was not told, not a word. People, all the responsibility was rested only on people. Yeah. You know that Bryukhanov, Fomin, yeah, director, the senior engineer, the deputy of senior engineer, Chernobyl nuclear power plant shift supervisor, the head of the reactor shop, they got 10, 6, 5, 3 years of prison. Yeah. Being in prison, Dyatlov, he wrote in his reminiscences that this very situation could and should be prevented, but not at the level of operation. It should be prevented at the level of a design activity. These very people who were at the control room of unit number 4, who worked inside unit number 4 rooms, they heard the explosion. Yeah, they heard. But they were 100% sure that it was the explosion of a reactor. They thought it was the explosion of some other equipment, reserved water tanks of control and protection system, which were located at the central hall. Yeah, they were it was beyond their understanding, beyond their comprehension, that it was the explosion of a reactor. They were taught at the universities that this very type of reactors, they were so safety, so reliable, they couldn't explode a priori. Yeah, a priori. That's why the first reaction, they were shocked, completely shocked. They did everything in accordance with their acting instructions. Yeah. They did everything correct. These were the first words of Akimov when reactor exploded. We did everything correct, because it was not mentioned in the instructions that this very type of reactors, they were poorly operated at low capacities. Well, Bryukhanov came to the control room maybe an hour after the explosion. Yeah. Akimov reported, yes, there was the explosion, but it was the explosion of the other equipment. The levels of radiation, they were not very high, just 3.6 Röntgen per hour. Remember, because the devices, measuring devices available, they were of a very weak capacity. Whatever they measured, they ran off scale. Yeah. All the other devices, they became blocked in the room, which was located near the central hall of reactor number 4. That's why wherever they measured, it was 3.6 Röntgen per hour.
Because that was the limit.
Yeah, yeah. This very information, it was sent to Moscow. Not so high, not so risky. Yeah. Dyatlov, the first thing, he looked at the devices. Well, no pressure or water in the reactor core. The risk of melting, nuclear fuel melting. He gave a command to pump water, to use all the pump systems to pump water to the reactor core for its cooling. And they pumped water. The whole night, the water was pumped to cool the reactor. But this very water, it couldn't get to the reactor core, because there was no reactor core. It had been destroyed completely. All the communications had been destroyed completely. This very water, it was accumulated at the lower levels of the destroyed reactor 4. Yeah. At pressure pool. Yeah. I will show you at the model a little bit later. The next day, firefighters began to pump this very water out, active water. Some of the deeds, you see, because of this very information which was false, which was not correct, some of the deeds, some of the works, they were purposeless, useless. Yeah. It cost people life. Yeah. They didn't know what to do. There was no information what really had happened. Only when they went outside, they saw the fragments of nuclear fuel, the fragments of graphite cladding. Understanding came that there was no reactor core. And we have to go faster. Yeah. Please keep as a group, yeah, and go faster.
Mm-hmm.
Okay. Everyone is ready?
Mm-hmm.
Mm-hmm. That is the entrance to unit number 4. Now we are approximately 100 meters far from the destroyed reactor core. 100 meters far. Okay, let's go. Please, no pictures here. Yeah, access point, no pictures here. You do not step into these very containers. Yeah, they are for the decontamination. Okay, let's go. The control room of unit number 4. That is the control room of unit number 4. It's a historical place where all the decisions, travel decisions, were made. We would please visit area faster, faster. A little bit faster. That is the area, the sign, where you can see the sign. The level of gamma is the highest, up to 10 microsievert per hour. That is the area where the level is the highest. This room is seems to be less than the control room of unit number 4, right? It seems to be less. This wall is a new wall. It was erected here only in 2011. When the project was started on the integrated automatic monitoring system, and the equipment is located behind the control wall. So it's less. It was not destroyed. When the reactor core exploded, this equipment was not destroyed. As part of the control panel, it was cut. It was cut. This very part was cut. You can guess the working places of the chief engineers. Reactor control engineer working place that you are people to know here. I do not give a command, let me talk to know press R05 red button. It was located here. R05 red button. Here. Unit control engineer working place, turbine equipment control engineer working places here.
Did you?
Alexei Breus,
You didn't take this one with you?
unit control engineer. He is not a guest, he was the participant of these very events. He worked the next day after the explosion. Shift number 2, he was a unit control engineer. Yeah. Not long ago he was here. He was here. He is a very frequent, let us say, visitor here at the Chernobyl site. And he told that he came the next morning, yeah, the 26th of April, but in the morning, the next shift. He and Leonid Toptunov, they were friends, yeah, they were friends. And when they met, they shake hands, yeah, greeting each other. Alexei Breus told me that after his shift, he had a sanitary treatment. The system showed that he was clean, not contaminated. But the right hand he shaved with Leonid Toptunov was contaminated. The only right hand. Yeah. Just imagine, Toptunov himself became the source of ionizing radiation.
For his friend.
Yeah. They were extremely... Toptunov, just imagine, he was very young. He was the youngest among them. He was only 26 years old. And he was a reactor-controlled engineer already. Okay.
Long enough?
Sorry?
Have we had long enough?
Okay, maybe step here, and you need an empty room to take a picture. Do you? Yeah. Yeah. So let us step here, take a picture of an empty room, and we will go. Take a picture of an empty room. Go. Do not need. You can be here. Other 5 red button is here, located here.
It's quite modern equipment, isn't it? Well, it's the monitoring. Julia, can you tell me what this equipment is?
That is integrated automated monitoring system. Yeah, the equipment which was mounted at the destroyed unit number 4, the system which ensured radiation safety and nuclear safety first. Yeah, these are boxes of nuclear safety system, yeah, the boxes of nuclear safety system.
Okay.
When this very equipment was mounted here, this very wall was constructed here. Yeah. First of all, the parameter, which is neutron flux density, yeah, is under control to ensure nuclear safety. Yeah. So we have sensors, detectors mounted inside the destroyed unit number 4, as close as it was possible to the surface of fuel-containing materials, measuring the basic parameters, including neutron flux density.
Understood. Thank you.
This very wall, it was original.
Yeah.
That was the original wall. It's
see.
a new wall. Have a look. Have a look. 0686. So June 1986. The level of exposure dose rate of gamma was 0.2 Röntgen per hour. Somebody wrote it at the wall in June 1986.
Wow.
Now we are approximately, 35, 40 meters far from the destroyed reactor 4. It is located behind this very wall. Now we are inside the arch structure. Yeah, this very control room is located inside the arch structure. Right? Okay. Let's go this way. Now step into this very containers for your shoes decontamination.
Yeah.
Now you have to do like this. Yeah. You have to go through this very cistern. You have to press your hands, place your hands to the detectors. Yeah. It will measure the level of surface contamination. Place your hands here. Okay. Not contaminated. It will be written here. Contaminated or not.
Oh,
No, no, no.
get your hand up a bit higher.
Close, yes, close. Good. It's good. It's okay. Yeah. Good. It's good. Sorry. It's okay.
I think red.
Good. Good. These are the main circulating pumps of unit number 3. Valery Khobinchuk. He was at the same area but opposite. Reactor 4 building is located opposite. He was at the same room, no room, main circulating pumps, but opposite. They were designed, these very pump systems, they were designed to ensure the circulation of a coolant in a primary circuit. We walked along and we saw this very wall from which they started to dig at now. We saw this very wall. So this way.
Sorry.
Do you need an empty corridor?
Yeah.
No.
He's done it now.
Okay.
He's done it now.
Now we are at the first stage of decommissioning program, and we have already started the dismantling of their equipment. Yeah. Turbines of unit number 1 and 2, they have been already dismantled. Just imagine 130,000 tons, all in all.
Wow.
All the equipment should be dismantled. 30,000 tons, that is their equipment. I'm sorry. Well, guys, little please.